Here are the learning objectives that we will cover in today's webinar. We'll learn the water quality standards for drinking water and stormwater, recognize various water sources and how discharges are treated, identify the key steps in a drinking water program, including testing, reporting, and corrective action, and understand the value of water quality testing and identify common pollutants. We'll first start with drinking water quality standards. Drinking water quality standards are essential to safeguard public health and well-being. Key parameters and contaminants that are typically regulated in drinking water include microbiological parameters, physical parameters, chemical parameters, radiological parameters, and secondary contaminants. Microbiological parameters, these include bacteria, viruses, and other microorganisms that can cause waterborne diseases. Common indicators for microbial contamination include total coliforms and E. coli. Total coliforms include bacteria that are found in soil, in water, that have been influenced by surface water. E. coli is the major species in the fecal coliform group. Of the 5 general groups of bacteria that comprise the total coliforms, only E. coli is generally not found growing and reproducing in the environment. Physical parameters, these include characteristics such as color, turbidity, which is cloudiness, odor, and taste. High turbidity may indicate the presence of suspended particles, while color, odor, and taste issues may result from natural or man-made substances. Chemical parameters, drinking water standards usually set limits for various chemical contaminants, including heavy metals, disinfection byproducts, industrial chemicals, and other organic and inorganic compounds. Radiological parameters, these include radioactive elements such as radon, uranium, and radium. Standards for radioactive contaminants are set to prevent adverse health effects. Secondary contaminants, these are substances that do not pose any immediate health risk but may affect the taste, odor, or appearance of the water. Common secondary contaminants include iron, manganese, and sulfate. Next, we'll talk about drinking water system classifications. Sources of water include surface water systems, which are water obtained from rivers, lakes, reservoirs, or other surface water bodies. Next are groundwater systems, which is water extracted from underground aquifers through wells and boreholes. Treatment methods vary depending on the type of system you're on. For a municipal water system, water is treated by a public utility or municipality to meet specific quality standards before distribution to consumers. In a private well system, water obtained from private wells without centralized treatment often require individual water treatment and testing. How you treat the water is based on what the water is being used for. A potable water system is treated to meet drinking water standards and to ensure that it's going to be safe for consumption. A non-potable water system, which is water used for various purposes other than drinking, such as irrigation, industrial processes, or flushing of toilets. Distribution systems are classified as either centralized or decentralized water systems. A centralized water system is water distributed from a centralized location, such as a water treatment plant, to residential and commercial areas. A decentralized water system, which is water distributed through small local systems or private wells, often in rural or remote areas. Now, treatment of water can be done one of 2 ways. The first method would be a point of use system, which is only treating certain sections of the distribution system based on its use, such as a kitchen or a bathroom, anywhere that you would use water to drink or to cook with, such as a water fountain or a dispenser. You would only be treating water just at that location. Point of entry system is a system that treats all the water that goes through the distribution system. So at the point of entry, depending on what you have, either a residential home, a small business, or an industrial building. The water would be treated right where it enters the building, and therefore everything in the distribution system would have treated water. Next, we'll talk about public water systems. Public water systems can be classified into two main categories: community water systems and non-community water systems. These categories are defined based on the population served and the type of users connected to the water system. Community water systems are those that provide water to year-round residents of a defined community, town, or municipality. The water supplied by these systems is primarily intended for residential use, but it may also serve commercial, industrial, and institutional customers within the community. Key characteristics of the community water system include providing water to a year-round population, serving households, businesses, schools, hospitals, and other establishments within the defined community. These are all subject to regulation by the Environmental Protection Agency under the Safe Water Drinking Act in the United States. Non-community water systems are those that do not serve a year-round residential population. Instead, they provide water to specific facilities or locations where people do not usually live on a permanent basis. Key characteristics of non-community water systems include supplying water to facilities or locations with transient or intermittent populations. Examples of non-community water systems may include factories, campgrounds, gas stations, hotels, office buildings, churches, and others. Also subject to regulation by the EPA under the Safe Water Drinking Act in the United States. Next, we'll talk about drinking water quality testing. The Drinking Water Quality Testing Program is a comprehensive initiative designed to assess and ensure the safety of the water supply provided to the public for consumption. This program involves regular testing and analysis of water samples for various sources, including municipal water systems, wells, springs, and other sources of drinking water. The primary objectives of a drinking water quality testing program are to ensure public health. The program aims to identify potential contaminants or hazards in drinking water that could pose health risks to the population. Compliance and regulations. The testing program helps water providers meet and adhere to local, state, and federal regulations and standards regarding water quality. Identify problems. By monitoring water quality regularly, the program can identify any issues or deviations from accepted water quality standards, enabling prompt corrective actions. Increase public awareness. Provide transparent and accessible information about water quality reports, builds public awareness and trust in the safety of the drinking water supply. Key steps in a drinking water program. Sample collection. Collect representative water samples from various points in the water distribution system. This may include sources like raw water, treatment plants, distribution reservoirs, and consumer taps. Testing and analysis. The collected samples undergo comprehensive laboratory analysis to detect a wide range of potential contaminants. Common tests include analysis for bacteria, chemical substances, and physical characteristics. Compliance assessment. Compare the test results against local, state, and federal drinking water quality standards and regulations. If any parameters fall outside the acceptable limits, further investigation and corrective action are initiated. Public reporting. Present the water quality results to the public in an accessible and understandable format. This could be through websites, public notices, or communication with local authorities. Corrective actions. If any issues are identified, take necessary measures to correct the problems. This might include implementing treatment upgrades, infrastructure repairs, or implementing water management strategies. Ongoing monitoring. Regularly repeat the test process to ensure continuous monitoring of the water quality and to maintain compliance with safety standards. Now we'll talk about stormwater quality standards. Stormwater quality standards refer to the regulations and guidelines set by government agencies or local authorities to control and manage the quality of stormwater runoff. Stormwater runoff is the rainwater or melted snow that flows over the ground and into storm drains, streams, rivers, and other water bodies, picking up pollutants along the way. These pollutants can include sediment, oil and grease, heavy metals, nutrients, bacteria, and other contaminants, which can have detrimental effects on water quality and the environment if left uncontrolled. The purpose of stormwater quality standards is to protect water resources, ecosystems, and human health by minimizing the negative impacts of stormwater runoff. These standards are typically designed to reduce pollution, promote best management practices, and ensure compliance with environmental laws. Stormwater quality standards can vary from one region to another, as they are often tailored to address specific location issues and water quality goals. Common components of stormwater quality standards may include water quality criteria, specific numeric limits or concentration thresholds for various pollutants present in stormwater, such as suspended solids, nutrients, bacteria, and metals. BMP requirements, guidelines and specifications for implementing best management practices to control and treat stormwater runoff effectively. These practices may include rain gardens, vegetative swales, detention basins, permeable pavements, and more. Construction site runoff control. Regulations pertaining to the management and control of sediment and erosion during construction activities to prevent excessive sedimentation and stormwater runoff. Illicit discharge and elimination. Provisions to identify and eliminate illicit discharges, which are any unauthorized or non-stormwater discharges into stormwater drainage systems. Public education and outreach. Requirements for educating the public about stormwater pollution and encouraging community involvement in protecting water quality. Monitoring and reporting. Mandates for monitoring stormwater discharges, assessing water quality, and reporting the results to relevant authorities. Stormwater management plans. The development of comprehensive plans by municipalities and industrial facilities to manage stormwater runoff and meet the required standards. Next, we have stormwater system classifications. Stormwater systems are essential infrastructure designed to manage rainwater runoff and prevent flooding in urban and suburban areas. These systems are typically classified based on their components and functions. The two main types of stormwater systems are combined sewer systems and separate sewer systems. Combined sewer systems are older, traditional systems that were commonly used in older cities. They collect and convey both stormwater runoff and wastewater from households and industries in the same network of pipes. During dry weather, the combined sewer system transports the wastewater to the treatment plant for processing. However, during heavy rain events, the system can become overwhelmed, leading to combined sewer overflows, where a mix of untreated stormwater and sewage is discharged directly into nearby water bodies. Combined systems are gradually being phased out in favor of separate sewer systems. Separate sewer systems are modern systems that have separate networks of pipes for stormwater and wastewater. Stormwater runoff is collected through storm drains and conveyed through a separate set of pipes directly to nearby water bodies, such as rivers or lakes, without being treated. Wastewater from households and industries is conveyed through a separate sewer system to wastewater treatment plants for proper treatment before discharge. Overall, stormwater system classification can vary based on local regulations, environmental considerations, and the level of urbanization in a particular area. The choice of stormwater management approach depends on factors such as available space, cost, environmental impact, and the specific needs of the community. Additionally, stormwater systems can be further classified based on their design and function. Traditional stormwater systems, these are designed primarily to manage and control the quantity of stormwater runoff. Traditional stormwater systems often use a network of storm drains, culverts, and retention basins to collect and control runoff, reducing the risk of flooding and property damage. Sustainable stormwater systems, also known as green infrastructure or low-impact development, aim to manage both the quantity and quality of stormwater runoff. They utilize natural features and engineered systems to mimic the natural hydrological cycle, promoting infiltration and pollutant removal. Examples include rain gardens, green roofs, permeable pavements, and bioretention swales. Detention and retention systems are designed to temporarily store stormwater runoff and release it slowly over time. Detention ponds hold excess water during rain events and release it at a controlled rate to prevent downstream flooding. Retention ponds, on the other hand, retain water permanently, allowing it to gradually infiltrate into the ground or evaporate. Stormwater treatment systems focus on treating stormwater runoff to remove pollutants before it is discharged into water bodies. Stormwater treatment systems may include sedimentation basins, filtration systems, and various other technologies that improve water quality. The stormwater quality testing program is a systematic approach to monitoring and assessing the quality of stormwater runoff within a particular area. Stormwater runoff is the water that flows over surfaces like roads, rooftops, and sidewalks during rain events, and it can pick up various pollutants such as sediment, heavy metals, nutrients, oils, and chemicals as it travels into storm drains and eventually reaches water bodies like rivers, lakes, and oceans. The primary purpose of a stormwater quality testing program is to identify potential sources of pollution, assess the effectiveness of stormwater management practices, and develop strategies to protect and improve water quality. Such programs are often implemented by municipalities, government agencies, and environmental organizations to comply with regulations and to promote sustainable stormwater management. Key components of a stormwater quality testing program typically include sampling locations, which is identifying and selecting strategic sampling points where stormwater runoff is monitored. These locations are usually chosen based on the presence of potential pollution sources or high-risk areas. Sampling frequency, establishing a schedule for collecting stormwater samples. This frequency may vary depending on local regulations, weather patterns, and specific study objectives. Water quality parameters. determining which pollutants and water quality parameters will be measured during the testing. Common parameters include turbidity, total suspended solids, nutrients, heavy metals, pH, and oil and grease. Laboratory analysis, sending collected samples to a qualified laboratory for analysis of the selected water quality parameters. The laboratory results provide data for assessing the level of pollution and identifying trends over time. Data analysis and interpretation, examining the laboratory results to assess stormwater quality, identify potential sources of pollution, and evaluate the effectiveness of existing stormwater management practices. Reporting and communication. Preparing reports based on the data analysis and sharing the findings with relevant stakeholders such as local authorities, residents, and businesses. Transparent communication is crucial to raising awareness and encouraging cooperation in mitigating stormwater pollution. Stormwater management strategies, using the collected data to develop and implement targeted stormwater management strategies, such as installing best management practices to reduce pollution or improve infiltration. Lastly, compliance and regulations, ensuring that the stormwater quality testing program complies with local, state, and federal regulations related to stormwater management and water quality protection.